All right, hey guys. Can everyone see the slides okay? Okay? All right, awesome. So my name is Dinesh. I'm a developer advocate at Google, and today I'm going to be talking about Google Cloud Datastore. So a little bit about me before we get started. Like I said, developer advocate at Google Cloud. I would consider myself a full stack web developer. I don't know what that means, but I consider myself that. Previously, I founded an IoT startup, and we're doing big data in agriculture, using like sensors to do irrigation control. And this is my first talk as a Googler, so woo, you guys are special. And you can follow me on Twitter, Dinesh, GitHub, or just email me old-fashioned way. Cool. So when you have an app you're building, you have to know where you want to store your data. And there's a lot of choices out there. You know, you have data stores and NoSQLs and SQLs and graphs and this thing and that thing. And what should you use and how are they all different? It's a really important question that you got to ask yourself before you start doing anything. So the first question is, how about SQL, right? This is a tried and true database technology, relational databases. So they store relational data, and relational data is great at storing complex relationships, and it supports complex queries. The join is the best example of this. You can join two tables together and get data that's related from one table to another. And the thing is, they have a really great track record. People have been using SQL databases since forever. But when you try to scale them out, it becomes difficult. You have to worry about sharding and replication and slaves and masters and this thing and that thing and getting out of sync. So it takes a lot of work and effort to do it. And flexibility is also an issue. Once you set up your schema, it's hard to migrate to another schema if you have to. How about NoSQL? It's a new kid on the block, right? Maybe like 5 years ago. NoSQL is a real general term. It encompasses a lot of different technologies. Basically, it's anything that's not SQL, right? So I'm just going to put in some very general categories. And the truth is, like, these things can go into any category you want, depending on what you're doing with them. So you got like document stores like MongoDB or CouchDB. These are pretty flexible and have very powerful query languages. Sometimes they're a little bit difficult to scale. Again, you got to worry about masters and slaves and replication, things like that. But they're pretty good. You got your graph and triple stores and kind of esoteric databases. These can do super complicated relationship mapping. You know, you can find every plumber in Seattle that's related to my second aunt, cousin's former roommate, right? And click enter, and it will do that and map it out in the huge graph network. And they have special query languages like Sparkle and things like that. But performance can be a big issue, and they're usually built on top of another type of database. Then you got key value stores like Redis or Aerospike. Now these are really, really fast and really horizontally scalable. But they're kind of simplistic. It's a key value store. You can't do very complicated things with them easily. And you got distributed databases, and like Apache HBase and Cassandra, things like that. And these are pretty scalable, a little bit more limited again, and are usually built on Google Bigtable technology. So before I go any further, if you do want to use SQL, we offer a hosted SQL service called Cloud SQL. And today we just launched a hosted HBase called Cloud Bigtable. And it's literally the HBase API and literally the SQL API straight up. So it's pretty cool. But I want to talk about Datastore. And that's why you all came here. And why should you care? So, a little background before we get started. Datastore was meant to be the storage layer for App Engine. And how many of you have used App Engine or have heard of App Engine in here? Okay, so a fair amount. And how many of you have used Datastore? A little bit less. Okay, so when App Engine was created, we wanted something that could scale indefinitely, right? So if you got slashdotted or Reddit hugged to death, your website would not go down. And you wouldn't have to worry about, oh my god, I got a provision of 100 VMs tomorrow, and what's going to happen, and this thing, and that thing. It just scales for you. But you also need something that scales for you in the database layer as well, because your front end can scale great, and if you're lagging on database, it doesn't mean anything, right? You're still going to get a lot of lag. So Google Datastore was invented to try and alleviate that pain. And Datastore is built on a technology we use for pretty much everything at Google called Bigtable and Megastore. And powers Gmail, search, maps, Earth, what name you pretty much powers everything at Google. So we took that technology and ported it over so you could use it in your App Engine app. In recent years, we've kind of decoupled the two, so now you can use Datastore as a separate entity as well. So what does it give you? When you're building an application, these are the things you don't want to worry about. You don't want to worry about scaling, and you don't want to worry about performance, and availability, and sharding, and replication, and who knows what. Because it's a managed database service, it takes care of all that for you. So, in a list of buzzwords, Google Cloud Datastore is fully managed, NoSQL, ACID database that's built for scale with high replication and high availability. What does that all mean? All right, so fully managed, right? Google DBAs are your DBAs. This means that you don't have to worry about patching your database and upgrading your database and things like that. Everything's kind of taken care of for you in the background. We do rolling updates and things like that, so you always have the latest and greatest, and you don't have to worry about it. It's NoSQL, so I'm going to call it semi-structured data. It's not completely like Wild West. You structure your data in a way, but you're not locked in like a SQL database would make you locked in. You've seen that there. But because of the semi-structured nature, you still get very powerful query abilities as well. You can't do things like joins, but you get a lot of cool query abilities. And it's ACID. So what does ACID mean? First A is atomic transactions. So when you put something in a database, it would really suck if you put something in and half of it went in and the other half was garbage. And then it says success. And now you try to query it and it's like half garbage. And you're like, wait, what? It's much better if it fails completely or it succeeds completely, right? So if it fails completely, you know you gotta try again. So that's what atomic transactions allow you to do, is it allows you to 100% know that data is going to be there or not there. So you don't have to worry about edge cases. It's consistent, and I put eventually in brackets, and I'll talk more about that later. So eventual consistency is what allows us to do scaling really quickly, really fast, without giving you a lot of headaches. But what this means is, if user A and user B try to access the same data, eventually they'll get that same data. You won't have to worry about one database being completely out of sync with the other. Eventually it will all be consistent. And it's reliable. Built for scale. So what does this mean? It's built for Google Scale, great. But what it really means is it's scalable by design. So when you write your data store objects, right, you're almost forced to write it in a way that allows scalability. So something like MongoDB or MySQL, you could write a very unscalable app in those database technologies. And then later on, you're like, oh my God, I have to re-architect everything to make it scalable. Because those databases will scale if you do it the right way, but you can do it the wrong way too. With something like Google Datastore, it almost forces you to do it the right way from the beginning. High replication and high availability. So asteroid proof, what does that mean? If an asteroid hits a data center, you still won't lose any bytes of data that you've said successfully stored in Datastore. We use a really cool algorithm that kind of like distributes it and stuff that's way over my head, but it works. And our SLA is 99.95, just like App Engine, so you get a really good uptime. Cool. So now let's actually look at using Datastore and get a little bit deeper into what exactly it is. So in my opinion, the easiest way to understand how Datastore works is to compare it to a traditional RDBMS, right, or a SQL database. So you have something like a kind, and that's like a table in a SQL database. A row would be an entity. Your primary key would be a key, and a field would be a property, right? So let's take a look at a quick example right here. So let's say you have a kind called employees, right? So it's storing all your employee data. Each employee in this table, right, or kind, would be an entity. Now each employee would have a key, so like the employee ID number, right? And then you would have your properties or fields, right? Name, address, title, compensation, where they live, things like that. So that's pretty much the basics of how Datastore works. Now, this is what I kind of hand-waved over before. Let's talk more about it now. Eventual consistency versus strong consistency. Now, strong consistency is what traditional databases offer, right? Every time you ask a database, give me this data, it's going to give you that data. And it's going to be the same for everyone. The problem with this is it makes scaling very difficult, right? If you have millions and millions of users and like hundreds and hundreds of databases all over the world, if you're going to wait for everything to sync up, you're going to cause massive, massive lag. So the cool thing is Datastore supports both eventual and strong consistency, and allows you to pick when's the right time to do what. So let's talk about eventual consistency. So let's say we have 2 data centers, and we got 3 users. User 1 and 2 are pretty close to data center 1, and user 3 is pretty close to data center 2. So that's kind of what they picked by default. So let's say user 1 puts in some new data into the data center. So it goes into the first node, and then it replicates pretty quickly into all the other nodes in that data center. Now, when user 2 and 3, if they immediately try to query that data, user 3 with eventual consistency is going to get a little bit old or stale data. User 2 is going to get that new data because he's using the same data center. In a matter of seconds or minutes or whatever, how big your data is, it's going to be replicated over to all the other data centers. And now user 3 will get that new data. So now eventually, right, everyone is consistent with that new data. Everyone's fresh. Now let's look at strong consistency with the exact same example. Now user 1 puts in that new data. It replicates quickly. And now user 2 and 3 try to read it, but it's locked. Why? Because not everyone has it, right? So it has to wait for it to get replicated, and now everyone gets the new data at the same time. So you can see there's trade-offs in both. Sometimes you don't want people to get old data. You want everyone to be on the same page always. Sometimes that's not as important. Scalability is more important. So I'm going to talk about how we do that in Datastore. We have a concept called an entity group, right? So before I showed you that employees and then each employee was an entity, you can group employees, like maybe like all the accounting people are one entity group, and all the programming people are one entity group, and all the marketing people are one entity group, right? And with these entity groups, you can ensure strong consistency within each group. You do that by giving them all the same ancestor, right? So everyone who has the same ancestor is strongly consistent with everyone else. So all your brothers and sisters are strongly consistent with you. What's the downside to do this? Why don't I just put an ancestor key on everyone and then make them all strongly consistent? The way to ensure strong consistency in Datastore is we limit your writes to 1 per second per entity group, right? So if you have like 20 entity groups, you can write to each entity group once per second. So on aggregate, 20 per second, right? If you have 2 million entity groups, you can do 2 million writes per second. We don't limit the reads because it's a very read-heavy database. That's what it's really designed for. But we do limit the writes, and that's what allows us to be strongly consistent. So you have to pick and choose when you want to be strongly consistent and when you want to be eventually consistent. So let's look at some common types of queries and the default parameters for these. So the first one is a global query, right? Something like find all employees in the company whose first name is Tom. This is an eventually consistent query. We're just basically querying the whole kind, and we're not giving any sort of ancestor reference for it to use. So this is going to be eventually consistent. Now you have key queries. So this is like, find me all the data on employee number 1, 2, 3, 4, 5. This is going to be strongly consistent. We know exactly what you're looking for, so we can go exactly to that place and find it. And then we got ancestor queries. And this is when you say, find me all people with the first name Tom who work in accounting, right? And that we know, okay, look in the accounting section, we can make that strongly consistent. Okay, so that's pretty much the example, right? So let's just get into code because that's more fun. So APIs, let's talk about APIs real fast. When you're using Datastore with App Engine, there's a built-in Datastore API in App Engine. And it's really fast and really great. And when you combine it with Memcache, it's even better. But we also have an external API, so anyone can access it. I'm going to access Datastore straight from my laptop, right? And this is with either JSON or Protobuf, your choice. but the thing is, when you're doing an external, you had to go through a lot of more network layers, right? So think of it as a local disk for App Engine versus a network disk for the external API. What we've typically seen is most people use Datastore with App Engine because they work so well together. So it's going to be a lot faster than this demo. That's what I'm trying to say. And so you can program directly to that JSON or Protobuf API. But a better way to do it, my opinion, is to use the G-Cloud library. So these are idiomatic and open source libraries that are available on GitHub. All the development is done on GitHub, so it's great. Right now we have support for Java, Ruby, Python, Node.js, and Go, all great languages. I'm going to be using Python for this demo just because I can do it in real time. So what I'm going to do is kind of build a message board, like basically you can post comments and post stories and like write comments about those stories and things like that. The full code with the Curses UI is available in that link. And then disclaimer, all code I'm going to write is copyright Google and licensed under Apache version 2. Just got to say that. Apache version 2 means you can use it as much as you want, so don't really worry about that too much. Okay. So the first thing we're going to do is install the G-Cloud library and the Google API Python client library. I've already done this, so I'm going to skip that step. And then we go into our Google Cloud Developer Console. That's cloud.google.com, and then you click the little console link. So you click Create Project, make a new project. Once you do that, you go to the API section, and you click Enable API, and then you do some credential stuff. I'll just do it right here. So let's say I'm in this test, right? I just made a new project. First thing I do is go to APIs. I search for Cloud Datastore. So here we go, Cloud Datastore API. Click it. It's already enabled, so I definitely don't want to disable it. Then I go to Credentials. Once I click that, I want to click Create New Client ID. Then I want a service account. This is probably the easiest way to do authentication. And then I click Create Client ID. At this point, it'll download a .json file that has all the configuration that I need, right? And I just put that on my server, and it can talk to Datastore, or any actual things that I've enabled in this project, which is pretty cool. One thing for every single service. All right. Cool. Okay, and this is kind of the architecture for what we're going to do here. We have users, right, and they have an ID, which is like their email and the name. We have stories, which have a name, a URL, and some text. And then we have comments, which have a text and a story ID. So the question here is, why did we make comments ancestor the story? Wouldn't that make sense? Like, the comments that belong to a story belong to that story? You'd think so, but what happens is, remember, entity groups are limited to 1 write per second. So if you have a really hot story, say you're on the front page of Reddit, you can only write to that story once per second. That is like pretty bad, right? What makes more sense is to put the ancestor as the user. Now, if we do that, the user is limited to 1 comment per second. But that makes sense. You don't want a user spamming your website anyway, right? And because it's strongly consistent, when that user looks at his comments are always guaranteed to show up in the list, right? It's okay if like some random Joe from Canada, his comment takes a little bit of time to sync up. That's not a big deal for something like a message board. But if my comment doesn't show up when I post it, I'm gonna be like, this website sucks. If my comment didn't show up, and then you're gonna put it again and click enter, and now you have 2 comments, and they're a duplicate. And people say, why did you say it twice? And you're like, no, I'm sorry, right? So that, you don't want that scenario happening. So what we want to do here is make the ancestor of each comment the user itself, and the story ID to point to the story. Okay. So let's run some coding. Okay, so first thing we want to do is import. So we're going to import the Datastore library. And then okay, so we're just importing some libraries. So the G-Cloud library pulls configuration information from the environment. So I'm just going to set that up right here in Python. copy this little thing right here. I'll go through what this is doing. There's no way I can memorize that. So I'm saying my application credential is that JSON thing that we downloaded. My project ID is mythicalgeo93517, and that's just, you can see right here, if you go overview, that's my project ID for this project. Then I'm going to say my default dataset ID is equal to the project ID, my project ID is equal to the project ID, and I'm going to set datastore set default dataset ID equal to the project ID. Okay, so before I show you anything more, I showed them this before, I'm just going to go to my Cloud Datastore dashboard and just delete everything that's in there. So yeah, we have a pretty good GUI. It's nice. Cool. So now our data store is pretty much empty. You can look here. We have not stored anything yet in Google Cloud Datastore. Great. Okay, so let's start storing some stuff. So the first thing we want to do is create a new user so you can log in, right? So how we can do that, let's say you want to get their email. So email equals me @fake.com. Yay. Great email. Of course. Gotta give them quotes. Okay. All right, so we got the email. So now let's create a key for that user. So we're going to say key equals. And so here is the first thing. So when you're making a new key, you tell it what kind. So the kind is user. And you tell it the unique identifier if you want to, right? So email. That's the unique identifier for this user. Okay. So now what we want to do is create the entity, right? So we have the key, now we're going to make the entity. So let's call it new user. So now we have the key, and the key is just the key. And this is cool. So now if I say new user, it's going to say user kind is a user, and the name is me@fake.com. The name is a unique identifier for this user. So now let's give it some more information. So we say new user name equals. And new user, let's say their email. Is that email. Oops. Okay, so now if I look at the new user, you can see that basically there's the entity kind user name me@fake.com, and then we have a dictionary, right? So it's very Python, right? In whatever language you're using, it's going to be native to that language. Name, Dinesh, email me@fake.com. Great. Okay, so now we have that entity created. Let's put it into Datastore. So Datastore. That's pretty much it. So you might notice if you're Python people here that new user is in a list, and when you, any sort of command like get or put is all list based. So you can actually put in multiple people in the same transaction, and that's actually recommended because it's a lot faster. You don't have to like loop through and put. You can just do it in one transaction. It's a lot quicker, a lot less network traffic, things like that. Let's put it in. Cross our fingers. Okay, so it put it into the database. So now, if I refresh, that's awesome. So query. So now look, it all came up, right? Easy stuff. So it's actually went all the way to the cloud into our database. Okay, so that's great. Now let's get that new user from the database, right? So let's say, again, key is just our key. So what we can do is we can say datastore dot get key, and it went and got that object from database and show it to us. This is like database 101, so yeah, awesome. So that's kind of boring. Let's do something a little bit more interesting. Let's put in a story. So it's going to be pretty similar. Let's go data store. Let's go new story. Data store. Again, data store entity, right? Let's call it a key equals data store. And the type, of course, is story. And that's it. I'm not going to give it a unique identifier, right? Data store is going to make a unique identifier for me. And this is the recommended way of doing it. Monotonically increasing things like 1, 2, 3, 4, 5 is really bad for data store. It's a lot better to, if your ID doesn't really mean anything like tangible, it's way better to let data store handle it for you. It gives you a lot better performance. So let's do that. Okay, so now if I go new story, here it is. It's just a kind of story, and you might notice there's no like key information here, right? Because it's done when you actually put it into the database. And you might notice when I made that entity, I actually made the key inside the argument itself, which is pretty cool, kind of Python. Okay, so let's set some stuff for that new story. Let's say the URL is cloud.google.com. Let's give it a title and say, this is awesome. I'm really bad at titles. Probably want to Reddit post on Google too well. All right, this is awesome, and let's do some text. Check this website. Whatever. Okay. And I'm also going to give it a timestamp, right? So I'm doing this all manually, but you kind of understand how this would happen in a real program. It's very important when you're using Python 2 that you wrap all your strings in Unicode, because by default it's binary, and that does not look nice when you put it into data store. If you're using Python 3, you're fine. So here, I'm just getting the current time. So now if I look at my new story object, there you go. So that dictionary is populated with all that data. So now let's put it in the database. So data store dot. Awesome. So now we go here, refresh. And we look at story, we can see that it came in. And you can see here, the text is all corrupted, right? That's because we did not wrap it in Unicode. So let's do that again. Actually, it's okay. So it's corrupted over here, but Python will automatically use it, so it's fine. If you're going to use different languages and stuff, I really recommend using Unicode. Okay, so now let's do a get on that, just to make sure that we can actually get it. Oh, oops, not the story. We need to get data store dot key, and we're going to put in that randomly generated ID right here. So like this. Of course, you gotta give it what kind of object it is. So this is the story. There you go. So I gave that unique ID and I got that key back really fast. So that's great. I mean, I'm not going to know the ID every single time, right? So how can you get these stories out without giving the key every single time? To do that, you use something called a query. And this is kind of the cool part. So we say query equals data Okay, and then we can say, let's just do a list, query dot fetch. There you go. So now we just queried every single story from the database and printed it out, right? So if I do another story, well, let's change the timestamp, or let's change this one to again. Okay, and we put another one into our database. Now when we do that query that fetch, oh, got it wrong again. There we go. So we can see